Hello Algebra 1. This video lesson is about linear combinations and how to use this technique as a method for solving linear systems. It is the third method that we've learned, and it will be the last method that we'll learn for how to solve linear systems. It's based on chapter 7.3 in your textbook. I got to tell you, linear combinations I think is the fastest and best method of the three that I'm going to teach you. So I strongly recommend that you learn this method clearly. It'll help you a lot if you do. It's the method that I use most commonly myself. So let's look at an example. And often in this video I'm just going to walk you through the different examples, but I'm going to add my own different spin on things in certain cases. Alright, here I've got two different lines, two different linear equations. And I want to find out what x is and y is. In other words, I want to find out where those two lines cross. Well, the first two steps I'm going to explain in a minute. The textbook says make sure the equations are already arranged. Don't worry about that for now. The second says make sure that that you've got coefficients that are opposites. Well, quickly, let me just show you what they mean here. They've got plus 3y and minus 3y in the two equations they've picked for you. Well, the nice thing is those things are going to cancel out if you add them up. And that's exactly what you do here. Because those two cancel, well, 4x plus 2x becomes 6x, and 16 plus 8 becomes 24. Alright, now let's look at another example where they are not already opposites. 4x is not the opposite of 4x, it's the same thing. So they're not going to cancel if you add them. There are two ways to attack a situation like this, and I'm going to show you both. The one on the left that I'm going to put down here in just a second is what I tend to do in my head, but really I want you to start by understanding the technique on the right. The technique on the right is what the textbook uses, and it makes a lot of sense at the beginning until you're ready to do all of this in your head. What they've done on the right here is they've changed not just the sign of this to make that cancel, but because they changed this sign, they had to change every sign. So instead of plus 4x it became minus, instead of plus 5y it became minus, and so on. So let's talk about the one on the right, and I'm going to quickly get to that. I've canceled the 4x's because 4x minus 4x, after all, is negative 8y. And negative 3y plus negative 5y is negative 8y. Negative 3 plus negative 5 is negative 8. What I'm doing in my head is saying 4x minus 4x is 0, negative 3 minus 5 is negative 8, and negative 3 minus 5 is negative 8 again there. It doesn't matter whether you do it the left way or the right way, they'll both work. But I see the textbook's point. They recommend that you start by understanding that you are multiplying everything by negative 1. Okay, so what I had in the textbook's example, if 6x was equal to 24, then x had to be equal to 24 divided by 6, which is 4. Similarly, on the right, I've got negative 8 divided by negative 8. In other words, y is 1. And I have that in either case. Now, whoops. So that's a key point for you to realize. It didn't matter which of these two ways I did it. I still ended up with the same answer. All right, now moving on to step 4 here. Once I've got one of the letters in the example on the left, the textbook's example, I've got x equals 4, I can substitute that 4 in place of x. X means the same thing as 4. So I can put it back in. They've chosen to put it into the first equation and solve for y. So they're putting, instead of 4x plus 3y, they're going to say 4 times 4 plus 3y equals 16. Alright, well 16, you move that over, and it becomes minus 16, so you've got 3y equals 16 minus 16. In other words, y equals 0. Now you've got both the x and the y. You've got the place where the two lines cross. The next thing you would do is check and make sure that that's really true. Plug 4 and 0 back in to both of these equations, and if you do that, you'll find both of those equations work. So sure enough, 4, 0 is the right answer. And make sure you understand, it's not x equals 4 and y equals 0. That's not the answer. The answer is the point where they cross, and the point where they cross is 4, 0. Okay, as I said, they chose to plug, whoops, don't want to select that. They chose to plug 4 into the first equation. You don't have to do that, and I'm not going to. I'm going to plug y equals 1 into the second equation. The second equation says 4x plus 5y equals 5. Well, instead of y, I'm going to put parens and stick 1 in there. 4x plus 5 times what I know y is equals 5. That means 4x equals 5. Move that 5 over, minus 5. Or in other words, x equals 0. And so my solution for the question that I've added to the textbook's example is the point 0, 1. Okay, based on those two examples, go ahead, try this one, hit the pause button. When you come back, I'm going to show you the worked out solution to it. Okay, I'm going to assume that you've done that you've paused and tried it and are ready to see the answer. The answer is negative 2, 4. Let me quickly walk you through this. Notice that the 3y's canceled. 2x and x added to make 3x. Negative 16 and 10 added to make negative 6. If 3x is negative 6, then x is negative 2. Once you know x is negative 2, you can put it into either of these two equations. This time I chose to put it in the first one. Plug that negative 2 in there. And once I worked it out, I figured out that y turned out to be 4. So like I said, the answer is not x is negative 2 and y is 4. The answer is the point, negative 2 comma 4. All right, another example. Sometimes it's not quite as easy as the first example, the examples that we've looked at so far. Notice this time it's not perfectly set up so that anything cancels. The x's aren't going to cancel just by adding or subtracting, neither will the y's. But they are already arranged, and I'll talk about that in example 3. So to get them to be opposites, and you need the, either the x's or the y's to be opposites, you can multiply. Let me show you what I mean. Instead of calling it 3x plus 5y, I could multiply everything by 4 in the top row, and I could multiply everything in the bottom equation by 3. If I do that, multiplying by 4 here, 3 times 4 becomes 12x. 5 times 4 becomes 20y. 6 times 4 becomes 24. Similarly down here, negative 4 times 3 becomes negative 12x, and so on. Notice what I did. The numbers that I picked here to multiply by were the opposites of these numbers. That way they were going to cancel each other out. 4 times 3 is 12, just like 3 times negative 4 is going to be negative 12. Now those guys are going to cancel, the x's are going to cancel, and I'm going to end up with 20 plus 6, or in other words 26y equals 24 plus 15, or in other words 39. Y is equal to 39 divided by 26, which is 1.5. Now I know what y is. I plug 1.5 in place of y into either equation. This time the textbook picked the second equation. As I said, it doesn't matter which one you plug it back into. And once they did that, they figured out that must have meant that x had to be negative 0.5. And so the solution, the crossing point of those two lines, is negative 0.5 comma 1.5. Okay, here's another one of those for you. Hit the pause button, work this one out. When you come back, I'll show you the solution. Okay, I'm going to assume that you did that. I hope you weren't tricked. This time, you didn't have to multiply both rows. The example that I gave, you could just multiply either the bottom row. If you did that, if you multiplied the bottom row by 3, then this becomes negative 9x and those will cancel. Or you could have chosen to multiply the top row by 2. In that case, that would become negative 8y and those would cancel. So notice what happened here. On the left, the blue version, when you multiply by 3, here's what you end up with. The second row, instead of negative 3x, became negative 9x. Instead of 8y, it became 24y, and so on along here. In the right example, the red example, 2 times 9x made 18x, 2 times negative 4y made negative 8y, and 2 times negative 18 made negative 36. So notice in each case I kept one of the two equations. I didn't have to change it. In the left example, the blue example, I left the first row alone. In the right example, the red, I left the second equation alone. Because now I can put these together and they'll cancel. The 9x's are going to cancel in the blue example. The 8y's will cancel in the red. So on the left, I'm going to figure out that y is 0. On the right, I'm going to learn that x is negative 2. Then, plugging back in, I don't care which of these two ways you did it, either the left way or the right, you should have ended up finding that the place where those two lines cross is at negative 2, 0. Hit the pause button, study either of these two examples. You don't need to do both, but study either one if you didn't get this answer and come into class with questions if you have them. I'm going to move on and assume that you are clear on that or you're ready to come to class with questions. There is one more example I want to walk through in the textbook. That's example 3. I kept saying don't worry about whether or not the terms are arranged properly. Well, here's the case where they're not. Not only is there no canceling possible, but I don't even have like terms above each other. I have 2y above a term that doesn't have y in it. I have 3x above 2y. I have a constant above 5 at negative 5x. This isn't going to work at all. That just means I've got to rearrange them. Put the x's over each other, put the y's over each other, put the constants, the ones that just have numbers in them, above each other. Every once in a while you'll get a situation where they're scrambled and it's not obvious how to line them up. Once they're arranged, and that, remember, is step 1, then everything else works the same. And you should see, I'll let you study the textbook and read example 3 just in case you're not sure, but you should see that once they're arranged here, then it becomes the same process we've been talking about. And you'll find the solution, like they said down here. These two lines cross at the point 2, 1. Okay, so really what the textbook has done, and this box here is taken straight from the book, is lay out 5 steps. Step 1, do that arranging. The arranging only became important in the most recent example on the last slide. As long as they're arranged, decide, do you need to multiply either equation? Sometimes it's one, sometimes it's both equations, but sometimes you can leave them alone. But what are you going to do to make sure that you're going to get canceling? Step 3, well, the textbook says always add. That's fine. Sometimes I'm subtracting in my head, but I would recommend at the beginning that thinking back to that first example I showed you on one of the very first slides, that you follow the example on the far right column. That's what they're talking about here, so that you're always adding. Then, once you've got the answer, either x is 3 or y is negative 67 or whatever it is, plug that back in, substitute it back in. Once you've done that, then you'll get the other letter. You'll have the point. I still recommend you double check. It really is frustrating. This does tend to go faster than the other techniques, but even so, it's frustrating to get to the end and get the wrong answer when you've done all that work. That's it. It's the end of the video lesson. Come into class with any questions you have.